Good morning, students. As in a previous class, we have studied about some examples in which some conditions were given to us, and according to those conditions, we need to prove the questions. So, I hope that was clear to you. Now, today we are starting with a theorem. Name of the theorem is angle sum property of a triangle. As already you have learned the result of this, you have used the result of this theorem in your previous classes. Now, today we will be proving the theorem. That means we will be proving the statement of the theorem. As all of you are familiar with the statement of the theorem, I am writing the topic here, angle sum property of a triangle. Okay. Now, this is theorem number 6.7 according to your NCERT. Now, statement of this theorem is that the sum of angles of a triangle is 180 degree. Okay. First of all, we will be drawing the figure according to the given statement. As in the statement, it is given that we have to take a triangle for this theorem to be proved. So I have taken a triangle and named it as ABC. So I am writing here that given is ABC is a triangle. Then what we need to prove here? As you can read the statement says that the sum of angles of a triangle is 180 degree. That means we have to prove that sum of angles of a triangle, is to be 180 degree. Here I have written the given thing, that is ABC is a triangle. Now what is to prove? To prove, as you can see from the statement, we can write that angle A plus angle B plus angle C is equals to 180 degree. Then then we need to do some construction over here. So construction will be that you have to draw a line DE parallel to BC. You have to draw a line DE parallel to BC, which passes through the point A. Is this clear? Now you can see that I have constructed a line that is parallel to BC and that passes through a point A. So I am marking the angles which are being formed here. So I am naming it as angle 1, angle 2, angle 3, angle 4 and angle 5. Now I will be using this construction thing, that is I am using that DE is parallel to AC. So I will be writing here that as DE is parallel to BC. So according to that, what we can write, that you can see over here, as DE is parallel to BC and AB is acting as a transversal. So for AB is acting as a transversal, angle 4 and angle 2 are making as alternate interior angles. So we can say that angle 4 will be equals to angle 2. So I am writing here as DE is parallel to BC and AB is a transversal over here. Transversal over here. So what I can write? That angle 4 is equals to angle 2 because of alternate interior angles. As you all know about this angle, so I have written here that because of alternate interior angles. Now name this equation as equation number 1. Similarly, as you can see over here that if I will take this again, that DE is parallel to BC, where AC is acting as a transversal, then what we can write? That angle 5 is equals to angle 3 because of alternate interior angles. So I am writing over here. Now what I can write next? That as DE is parallel to BC and AC is acting as a transversal. Okay. So what I can write? That angle 5 is equals to angle 3 because of alternate interior angles. Okay, name this equation as equation number 2. Now, what else we can write? That as DAE is acting as a line, as DAE is a line. So what I can write? That angle 4 plus angle 1 plus angle 5 is equals to 180 degree because of straight line angles property. So I have marked here as equation number 3. Now what you can see that according to equation number 1 and according to equation number 2, we can replace angle 4 with angle 2 and angle 5 with angle 3. So in my next step, I am just replacing angle 4 with angle 2. You can see in equation number 1. So I am writing here angle 2 plus angle 1 I have written as it is. Then in place of angle 5, I am writing it as angle 3. And then copy this 180 degree as it is. So in bracket you can write because of from equation number 1 and 2. Okay. Now you can see in the figure itself that angle 2 is acting as angle B. Then angle 1 is acting as angle A. Then angle 3 is acting as angle C. And we can write it that it is equals to 180 degree. So this is only what we need to prove. So that's why we can say that angle sum property of a triangle is proved. So you can see that angles of a triangle is of 180 degree. Now next is theorem 6.8. Name of this theorem we can give as exterior angle property of a triangle. Okay, you can name this theorem as exterior angle property of a triangle. Now what is the statement of this theorem? Okay, this theorem we only understanding the result of this theorem, we will not be studying the proof of this theorem. So please listen it carefully. If a side of the triangle, if a side of a triangle is produced then the exterior angle so formed is equal to the sum of the two interior angles. Two interior opposite angles. Now, according to this statement, I am just drawing the figure first, and then with the help of this figure, I will be just telling you that what the property or what this theorem says. Now in this you can see that if a side of a triangle is produced, so I have taken first a triangle, then I have just produced this side of triangle to a point E. Then the exterior angles are formed. Now you can see that as I have produced this side to the point E, so one angle is formed, and that is exterior angle, you can say. Then that exterior angle so formed is equal to the sum of the two interior. We have to take two interior angles which are opposite angles, means interior opposite angles to this exterior angles. So interior opposite angles to this exterior angles are this and this only. You all know that, because this is not the interior opposite angle. Interior opposite angle will be these two angles only. So what can I write from here? I can write that angle C, or I'm just naming it. I can write that angle 1 is equals to angle 2 plus angle 3. Or you can write angle ACE is equals to angle A plus angle B. Now remember this result. This result or this theorem, these two theorems in fact are very important one. Please remember these theorem. Now on basis of these two theorems, we will be studying one example. First of all, I am drawing here the figure of the given question. You can see that a triangle is there which is named as PQR. Then now this angle is marked as 30 degree. This is marked as 40 degree. This is marked as angle Y, and this is as 90 degree, and this is as X. Now these two variables we need to prove. First of all, what is given to us? Now given is that angle, as you can see in the figure, given is that angle SPR is equals to 30 degree. Then angle TQR is equals to 40 degree. Then what else is given? That QT is perpendicular to PR. That means we can say that angle QTR is equals to 90 degree. Also angle QTP is of 90 degree. Then what we need to find over here? We need to find is X and Y. Okay. Now, how to find? As you have already used this angle sum property in your previous classes, you will be able to find it easily. Okay, we will use angle sum property of a triangle here. So, first I am going in triangle QTR. So, first we will go in triangle QTR. In triangle QTR. Here you can see that we can apply angle sum property, that is angle TQR plus angle QTR plus angle TRQ is equals to 180 degree because of angle sum property. You can write in the bracket that because of angle sum property. Then in place of angle TQR, we can write it as 40 degree. Then in place of angle QTR, we can write it as 90 degree. Then angle TRQ can be written as X. And then is equals to 180 degree. We can write it as it is. Then by this equation, we can find the value of X, and that will be X is equals to 180 degree minus 130 degree. That will be X is equals to 50 degree. So this is the value of. Now we will be find the value of Y. Okay. Now you can see that for finding value of Y, we can apply theorem 6.8. Okay. Now you can see here that PSR is acting as a triangle and Y is acting an exterior angle for this triangle PSR. So I am applying here theorem 6.8. I am applying theorem 6.8 in triangle PSR. So it says that, according to that, you can write it as angle PSQ is equals to angle SPR plus angle SRP. You can see here that this is acting as an exterior angle, and these two angles for this exterior angle are acting as a interior opposite angles. So what I have done, I have just written angle PSQ first. According to that theorem, I am writing it is equals to angle SPR plus angle PRS. As that theorem says that exterior angle of a triangle is equal to sum of interior opposite angles. So by using this theorem, we can write like this. Then we can just put the values as it is given in the question. You can see that in place of PSQ, we can write Y. Okay, this can be written like this, Y. Then in place of angle SPR, we can write 30 degree plus angle, in place of angle PRS, we can write X. Okay, and as you all know that we have found the value of X, so in place of that I can write 50 degree. Okay, I will write it in next step. I have written it as X only. Then in next step, I have written in place of x as 50 degree as we have found here. So this implies that y is equals to 80 degree. So I think till here it is clear to you. Students, you can write it side by side. It's better to write it side by side. After this, we will be doing one more example. Now, this example is on the basis of these theorems only. Only the difference is this time we have to prove the question according to the given condition. So I am reading the question first, that in figure, okay, I am drawing the figure first so that it will be clear to you that what is the question regarding this figure. This is E point. This is D point. Then this is X. This is Y. This is Z. Then what is given? That this is equals to this and this is equals to this. Okay. Now I am reading the question. Question is that in figure the sides AB and AC of triangle ABC are produced at the points E and D respectively. If bisectors BO and CO of angle CBE and angle BCD respectively meet at point O, then what we have to prove? We have to prove is that angle BOC is equals to 90 degree minus half of angle BAC. So I am writing given first. What is given to us? That BO and CO are bisectors of angle CBE and angle BCD respectively. Okay. Then, okay. Now, what we need to prove is, okay, I am writing this also, that it is given in the figure that angle ABC is equals to Y, then angle BAC is given as X, then angle ACB is given as Z. Now we need to prove is that angle BOC is equals to 90 degree minus half of angle BAC. Okay. Now, first I will take ray BO as a bisector, as it is given to us that BO as a bisector. So ray BO is acting as a bisector. So what can I write? That angle OBC is equals to half of angle CBE. Yes or no? As BO is acting as a bisector, that means this angle is equals to this angle. So I can write angle OBC is equals to half of angle CBE. Yes or no? Then in place of angle CBE, what we can write? We can write 180 degree minus y, because you all know that angle, because of, okay, I am directly writing that these are making linear pairs. Okay, because of linear pair. So I can write in place of angle CBE, I can write 180 minus y. Yes or no? Then if we multiply this half with this 180 and this half with this y, then what we will get? We will get it as 90 minus y by 2. So this will be the value of angle. So name it as equation number 1. If there is any confusion here, then you can write the reason over here, proper reason over here, that as angle CBE plus angle CBA is equals to 180 degree because of linear pair. Okay, you can write it like this. Then we will take that ray CO is acting as a bisector. So what can I write? That angle OCB is equals to half of angle BCD. Again, you can see here that CO is acting as a bisector. That means this is equals to this. So we can write that this is half of this. Then in next step, in place of angle BCD, we can write it as 180 degree minus Z. Again, we can write the reason because of linear pair. Here I am directly writing because you can see that I have explained the concept of this here only, because concept of this and this equation and this equation are same. So if we multiply half with 180 and half with Z, then what we will get in next step? That 90 minus Z by 2. So this is the value of angle OCB. Now we will go in triangle. Okay, name this as equation number 2. I hope you have marked that equation number 1. Okay, so name this as equation number 2. Now I am going in triangle BOC. If we go in triangle BOC, then we can apply angle sum property again. What it says, that angle BOC plus angle OBC plus angle OCB is equals to 180 degree because of angle sum property. Okay. Then in next step we can write angle BOC as it is. Then in place of angle OBC from equation number 1, what we can write? 90 minus y upon 2 plus, here again from equation number 2 we can write 90 minus z upon 2, and then copy this is equals to 180 as it is. Now because of equation number 1 and 2. Then you can see here that 90 plus 90 will become as 180 degree. Then minus y by 2 minus z by 2, we can write it as it is. Then in next step we can just cancel this 180 with 180. Then what will be left, you can see that if we shift y upon 2 and z upon 2 that side, so it will become like this, then angle BOC will become as half of y plus z. Now, after this, you can observe from the figure that y plus z can be written as y plus z. What it can be written as? It can be written as, I am writing it here, that as y plus z can be written as 180 degree minus x because of angle some property. Okay, so I am giving a small description of these angles here. As you know that x plus y plus z is forming 180 degree. So y plus z will become as 180 degree minus x. Then what will be the final answer? 90 minus x by 2. Angle BOC is equals to 90 minus x by 2. So this what we need to prove. Now come to next question. I am taking one question from exercise 6.3. Again an important question. Please listen it carefully. You can copy it side by side too. I am erasing it. Now question number 6 we will do here of exercise 6.3. I am explaining it. Please listen it carefully. First of all, I am drawing figure over here. Okay. Now we can mark it as PQR. Then mark this as T and this as S. Then this is given to us. Now okay, now first I am reading the question. Question is that in figure the side QR of triangle PQR is produced to side to point S. If the bisectors of angle PQR and angle PRS, you can see that QT and TR are acting as bisector, meet at point T, then we have to prove that angle QTR is equals to angle QPR. So I am writing what is given first. So given is that QT and RT are bisectors of angle PQR and angle PRS respectively. Then what we need to prove? We need to prove is that angle QTR is equals to half of angle QPR. Okay, now we are starting with that QT is acting as a bisector. First I am writing here that QT is acting as a bisector. So as QT is a bisector here, so what I can write? That angle TQR is equals to half of angle PQR. TQR is equals to half of angle PQR. Is this clear? TQR is half of PQR. Then name it as equation number 1. Then you can write that as TR is acting as a bisector. So what can I write? That angle TRS is half of angle TRS. Yes or no? So I can mark it as equation. Now we will apply exterior angle property in triangle QTR. So you can see here that angle TRS is acting as an exterior angle for triangle QTR, and angle RTQ and TQR are acting as interior opposite angles for triangle QTR. So I am applying here exterior angle property. So in triangle QTR we can write angle TRS is equals to angle RTQ plus angle RTQ, or you can write QTR. Okay, it will be convenient for you. QTR. Then plus angle TQR. Okay. Then you can see that, okay, we have to find angle QTR according to, we have to prove for angle QTR according to two proof in the question. So I am just shifting my TQR that side, and then we will find the value of angle QTR from this equation, and we will get angle TRS minus angle TQR. I hope till here there is no doubt. I have just shifted TQR to that side, and then I have found the value of angle QTR, so that it will be convenient for us for further steps. So you can see that we can put the value of angle TRS and angle TQR from equation number 1 and 2. So I'm putting here, I'm writing angle QTR as it is. In place of angle TRS, I can write half of angle TRS. Then in place of angle TQR, I can write half of angle PQR, and in bracket write from equation first and 2, we can write it like this. Then in next step we can take half common, and inside we will get angle PRS minus angle PQR. Okay. Then according to the question you can see that angle PR, it is written angle PRS minus angle PQR. So I can replace it by angle QPR because of exterior angle property. Okay. So I'm explaining one step over here so that it will be convenient for you to understand. I'm writing here one step. Further, we can write that exterior angle property says that angle PRS is equals to angle QPR plus angle PQR. Okay. In next step, you can see that we can find the value of angle QPR. That will be angle PRS minus angle PQR. So by this we can say that angle QTR is equals to angle QPR. This is what we need to prove. Now for today your homework is that you have to do question number 1 to question number 5 of exercise 6.3. After this, if there is any doubt, then you can take your doubts. Thank you.